So you're setting up that problem. Go ahead and pause if you haven't set it up yet. All right, so initially you are moving. You're at ground zero. There is work being done by a non-conservative force. You are moving. You're saying how fast, and you are above ground zero. We're going to say initial, final. Just my ground zero. Okay. How do we do? Okay. So you have 1/2 mass times speed squared initial. Is friction doing positive or negative work here? Negative. Okay. Good with that? Okay. So then let's start plugging in numbers here. Okay. Really important question. Can I stick in 5,000 there? What do those units measure? It's a Newton. What do those measure? Force in general. Weight, yes, is an example of a force. Okay. What's work measured in? Joules. Huh. Can I stick 5,000 here? No. How do I convert newtons into joules? How do I convert force into work? Think first lesson. Work is equal to force parallel times distance. Okay. This is a very popular pitfall. Please watch yourself. If I give you newtons, you need to figure out how much work is being done. So force parallel times distance. You okay with that? Yeah. Equals 1/2 mass final speed squared, 2,000 kilojoules, 9.8 times height. Should I stick in 100 there? What is 100? It's that distance there. Height is your elevation above ground zero. How could I possibly find my height? You got this nice little triangle here. Okay. So I'm looking for my opposite side. I've got hypotenuse, so I've got sine of 30. This is equal to height over 100 meters. Sine of 30 is 0.5. Find your height to be 50 meters. So we're going to have some big numbers here. So this is 5,000 newtons times, what's my distance? Is it 100 or is it this horizontal? It is 100. That's the distance the force is being applied, that friction is being applied to. Okay. So you got 100 meters here. I think that was, cool that, 10.95 meters per second. And that mathematically is the extent to which you need to be able to do calculations for the rest of the unit. Okay. So watch, if I give you newtons, you need to find the work. Distance is how far your non-conservative force is acting on it. Height is your elevation gain above ground zero. Good with that? All right. I'm just going to repeat that demo for the video audience. But that's it. What I got today. Okay. So the question is, who's going to win? Okay. Okay, you guys are going to get it. Crazy cool camera angle here. Okay, on your marks, get set, go. Blue, yellow, green, and red. That might be worth watching a video, guys. That was pretty cool. Okay, so then the follow-up question is which, oh dear, which track, which marble is going to go the fastest at the end? We know that blue wins, but which one's going to have the greatest speed once they cross the finish line? Take a guess. The way we're going to answer that is we're going to drop these off the ground. launch these off the table. I'm going to see how far they land. Good way to capture this shot here. Here goes red. Right there. So you get this idea. What's going on here? Hit it right there. Here goes green. Boop. Nice. About the same spot. Yellow. About the same spot. Blue. About the same spot. So, what can we conclude from this? Thank you. So why did that happen? Think about conservation of energy. Mechanical energy is conserved. So all the forces are acting on the marbles are gravity. What's a conservative force? And normal force, which is perpendicular to direction of motion, does no work. Mechanical energy is conserved. So they all have the same amount of potential energy up top, transferred to the same amount of kinetic energy on the bottom. So I'll have the same speed at the end. But so the takeaway on this one is if mechanical energy is conserved, then the path taken does not matter from the starting to the ending if we're comparing speed or height. The second thing you want to walk away from is working energy cannot tell us anything time-based. So anything in terms of like chronological order, working energy fails to do that. So, but if we're asking for height or speed, working energy are go-to. So